Here's a question from one of the mock papers. We're told that y squared minus x squared equals 8. And we need to show that the second derivative is 8 over y cubed. Okay, so this is going to be a parametric differentiation because we've got y's and x's in our argument. So let's start with the original argument. So y squared minus x squared equals 8. Okay, so we differentiate y first. So we get 2y. Now remember, we're looking for dy by dx. So that means that we differentiate y, and then we have the derivative of y, which is dy by dx. Minus x squared, so that's 2x. And the derivative of 8, any constant, is 0. So now we've got our first derivative. Let's write that as dy dx is equal to, add the 2x, and we divide through by the 2y. And now 2x over 2y, so that's simply x is y. So there's our first derivative. Okay, so now dy dx is equal to x over y. Now we can use a quotient rule because here we have a derivative which is a fraction. So we're going to make u equal to x and v equal to y. Remember, v is always the denominator. And so du, the derivative, is going to be 1. And dv is going to be dy by dx. Remember, we're working out dy by dx, and we know what dy by dx is. Right, so now we've got that. So now we use the quotient rule for this. So remember, this is a parametric, so we differentiate both of them. If I differentiate the derivative, I get the second derivative. So now I've got my dy by dx squared. That's equal to v du, which is y, minus u dv, which is x times dy by dx, all over v squared, which is y squared. Okay, now, let's see if we can tidy this up. We've got y minus x. Now, our derivative, dy by dx, we already found in the last part of the question. So actually, we can replace that with our dy by dx, which is x over y. Okay, and all of that is y squared. Okay, so let's multiply this out. And then we've got y minus x squared divided by y all over y squared. Okay, so this y squared, let's multiply by through because we want to get rid of this fraction. So we multiply the whole thing, every term, by y squared. So we get y squared times our second derivative, which is equal to y minus x squared over y. So now that denominator's gone. So we've just got this. Okay, we're almost there. Again, I've still got a denominator here. So I want to multiply through by y to get rid of this denominator. So the next step, multiply the whole thing through again by y. So now I've got y cubed is equal to the second derivative, which is equal to y squared now minus x squared. Okay, so now no more denominators, that's good. Now, from the original question, we were told that y squared minus x squared was 8. So replace that with 8. Y cubed is equal to y cubed times the second derivative is equal to 8. Okay, now what are we looking to do? We want the second derivative is equal to 8 over y cubed. Okay, well, then if we simply type this up, second derivative is equal to 8 divided by our y cubed. And that is our final answer. So it's simply parametric differentiation. The only complication being that basically once we get the first derivative here, we've got a fraction, so we just use the quotient rule, okay, which is always my first choice when we come to fractions. You can do this from this point using the product rule, but I think the quotient rule was easier to see and easier to use. Well, hopefully that was helpful.